Today I'm going to introduce the Haber Bosch process used in agriculture. The discovery of the Haber process more than 175 years ago, a scientific debate was raging in Europe over the importance of nitrogen for the growth of plants. British scientist Bennett Lewis, this one, and Joseph Henry Gilbert settled the debate when they published research showing that the addition of nitrogen fertilizer increased wheat yield in England. And 50 years later, the population is increased and Great Britain was importing the majority of its wheat. In 1898, William Crook, president for the British Association for the Advancement of Science, called for chemistry researchers to find solutions to aid in the manufacture of nitrogen fertilizer to help solve the coming food crisis. And the solution soon came from German scientist Fritz Haber, who discovered in 1909 that the chemical reaction of nitrogen and hydrogen produced ammonia, the main component in nitrogen-based fertilizers. In July of the same year, Germany's largest chemical company, BASF, founded by German chemist and engineer who's called Haber Bosch, to develop commercial scale production of ammonia. And the main problem and challenge it may have before this discovery. First problem is how could we improve the wheat yield? More than 175 years ago, the addition of nitrogen fertilizers increased wheat yield in England. And the second problem is produce the nitrogen fertilizers. How to solve it? The chemical reaction which is found by the Haber, that one nitrogen plus 3 hydrogen can produce 2 ammonia, and the reaction is exothermic reaction. And the third problem is the high temperatures and pressures from the ammonia production. How can we create this condition with the development of technology? In 1914, a 26 feet tall machine was created for the process, and it can produce approximately 198 pounds of ammonia per hour. Today, a modern ammonia production facility produced approximately 1,000 tons of ammonia per day, which is larger than before. And there are the reaction that happens in every single devices. This is the flow chart, and I will introduce it. I'm going to introduce it. The composition of the Haber Bosch process. The first process is the steam air reforming process. The feedstock is include some of the gas It is the most common method used in industry to produce hydrogen in large quantities. And the second process is the partial oxidation process. The feedstock include heavy oils and coal. The partial oxidation process is used in the production of ammonia from heavy feedstocks such as coal and heavy fuel oil. The third and fourth process is the shift conversion and gas refining. Shift conversion, the performance of the shift conversion is very important for the overall efficiency of the ammonia plant because unconverted CO will consume hydrogen and form CH4 in the methanator, reducing the feedstock efficiency and increasing the inert content through the synthesis loop. And the gas refining, in this process step, the carbon dioxide is removed from the process gas with physical or chemical absorption. And the last process is the ammonia synthesis. The nitrogen plus the hydrogen that can get the ammonia. And the first problem which will appear in the process is the catalyst poisons. The catalyst poisons will lower the activity of the catalyst. They are usually impurity in the synthesis gas. And the synthesis gas is a raw material. There are some examples. And one of the process which I mentioned before, the steam reforming process, the desulfurization can remove the sulfur compounds. And some of the oxygenic compounds like water, carbon monoxide, carbon dioxide, and oxygen are temporary catalyst poisons. And there's the gas refining which can get the carbon dioxide out. The second problem is the batch reaction conditions. We all know that the reaction is exothermic reaction, and according to the Chatelier principle, higher temperature and pressure is benefit to the reaction. We also need to consider the economy benefits. Higher pressure, which will if the machine is needed to suffer a high pressure, the cost of the machine must be very high. And the second, if we need a higher temperature, the cost of the energy must be very high too. So finally, we find the best economic condition is the 100 to 250 bar, and the temperature is 350 and to 550 degrees. And at last is the manufacture of nitrogen fertilizers, which use the ammonia and carbon dioxide and water to produce the nitrogen fertilizers. And at last, I think there are also many other useful chemical reaction reactions can be used in our lives, just like this Haber process. It starts from an imagination and finally achieved by our chemical engineering. The chemical engineering is so interesting and magical. I will pay more my effort to learn this magical subject. That's all. Thank you.